At the bottom of the world, there is a frozen and forbidding continent. A place so vast and extreme that only the most determined explorers have ventured there. Temperatures here can plummet to minus 80 degrees Celsius. Polar winds can erase tracks and swallow the horizon in seconds. Conditions are so inhospitable that many who have ventured across its barren expanse have never returned. Welcome to Antarctica. Ever since 19th century European explorers first reported sightings of thick walls of ice as far as the eye could see, Antarctica has captivated the minds of scientists and adventure seekers who would stare into the face of death to know more. For centuries, much of what lies on and beneath the continent has remained inaccessible. But thanks to modern technology, researchers have begun to peel back the ice, revealing astonishing discoveries, rewriting what we thought we knew about this isolated land at the bottom of our planet. I'm Jordan Ferguson, and you're watching See It First. Join me as we journey into the frozen heart of Antarctica and uncover what lies beneath the ice. Our journey begins over 250 years ago when James Cook, an 18th century British naval officer, navigator and explorer, set sail to discover Terra Australis Incognita, the unknown southern land. He never did find the vast temperate supercontinent he imagined. But on the 17th of January 1773, aboard the HMS Resolution, with HMS Adventure at her side, Cook and his crew did manage to achieve something that no one had done before them. After sailing over 100,000 kilometers, 62,000 miles, they became the first to cross the Antarctic Circle. Quite the feat, pushing south into thick sleet and snow that froze to the rigging until, as Cook put it, the ropes like wires and the sails like boards or plates of metal. Ahead, the water filled with hundreds of ice islands, and a solid white barrier dominated the horizon. Cook wrote in his journal that from the masthead, he could see nothing to the south but ice. Their journey reshaped European understanding of the southern polar regions and proved that navigating those icy waters was possible. But even though it was an incredible feat, neither Cook nor a single member of his crew ever set foot on Antarctica. The sea ice and treacherous conditions blocked their progress further south. And as a result, the continent remained a mystery. Decades later, in 1820, the Antarctic veil finally began to lift. Russian commander Fabian von Bellinghausen, on an expedition to systematically probe the far south, reported a towering wall of shelf ice at the continent's edge, while British naval officer Edward Bransfield sighted and charted the snow-covered mountains of the Trinity Peninsula. And later that same year, the American Nathaniel Palmer reported a sighting of Antarctic land while out hunting seals. The race to Antarctica had begun. But although their thoughts were consumed with fame and riches, the ability to survive in one of the harshest places on Earth soon took top priority. As they sketched the edge of this unknown land, every mile further south, the ice thickened and the temperatures plummeted. Britain, Russia, and America still argue over who saw Antarctica first, but at the time, none of them dared get close enough to touch it. It was on January 24th, 1895, when the Norwegian whaling ship Antarctic finally reached the coast near Cape Adare. The weather eased, giving them a gap of time to send a small boat through the freezing waters to the shore ahead. They went in as fast as they could, being ashore for only a few moments, but long enough to gather the proof: rock samples and lichens, real pieces of Antarctica. Then they turned back to the ship before the ice and sea could close up behind them. It's hard to put in perspective just how huge and formidable Antarctica is. At about 14.2 million squared kilometers, you could lay Antarctica over Europe and it would swallow it whole and still spill down beyond the Mediterranean. Temperatures here reach as low as minus 89 degrees Celsius, the coldest ever measured on Earth. Add in the screeching coastal winds, the isolation, and that even the smallest mistake can quickly turn into a matter of life and death. Exposure, frostbite, disorientation. Explorers of Antarctica have tested the limits of human endurance, risking life and limb for a glimpse of the great unexplored continent. Even today, Antarctica is still almost completely empty of human life. There are no permanent residents, just a seasonal population clustered in research stations. In the summer, when the ice retreats and flights can actually reach the interior, the number of people on the continent rises to around 4,000 to 5,000. But in winter, as darkness and extreme cold take over, it drops to roughly 1,000, cut off for months at a time. The sun can disappear completely with weeks of 24-hour darkness. At the South Pole, the polar night is roughly 6 months of continuous dark. For all its size, 98% of the continent is hidden beneath the surface layer. On average, the ice sheet is nearly 2 kilometers. In some places, almost 5 kilometers of solid ice is pressing down on the Earth below. To put that in perspective, the ice is taller than Ben Nevis, Scotland's highest mountain, and in the thickest places, it's nearly 4 Ben Nevises stacked one on top of the other. No sunlight reaches below, just permanent darkness and immense pressure, hundreds of times the weight of the atmosphere at sea level. The ice is a massive, crushing lid, sealing away what's been hidden inside. An ice tomb that we've only just begun to pry into. And every time we peel back another layer of Antarctica's ice, the discoveries are astonishing and completely unexpected. As polar scientist Robin Bell put it, it can feel like opening an Egyptian pyramid and finding an astronaut inside. Mapping the bed of Antarctica has proved extremely difficult. Surface measurements reveal hints of what lay beneath, but drilling through kilometers of ice was painstakingly slow, expensive, and limited by the extreme climate. Each small hole could only tell a fragmented part of the story. For decades, the continent remained a colossal mystery. The conventional view was that Antarctica was and would remain largely a blank canvas, inaccessible and unknowable. But over time, new tools and technologies have emerged. Ice-penetrating radar, satellites, and computer modeling have illuminated the frozen interior. And for the first time, scientists could trace the shape of the land, the flow of hidden rivers, and the presence of lakes preserved for millions of years. Aircraft fly over the continent and transmit pulses of radio waves down through the ice. These signals bounce back from internal ice layers, from the bedrock below, and sometimes from hidden bodies of water. The timing and strength of the echoes are what allow scientists to build a profile of the ice's thickness and the shape of the land beneath. Each individual survey only reveals a piece of the puzzle. A single flight traces a narrow line across this massive continent, offering just one cross-section into the unknown. But when you factor in thousands of flights over decades, a picture begins to emerge. A picture complete with hidden mountains, deep troughs, and networks of subglacial lakes stretching beneath the ice. A hidden world cut off from the outside. Satellites fill in this picture even further. They track surface elevation and subtle changes over time, measure the speed and direction of ice flow, and detect shifts in gravity that reveal where ice is thinning or thickening. Combining these satellite datasets with radar surveys and physics-based models allows researchers to fill in the gaps and produce surprisingly detailed maps of the Antarctic bed. This technology has revealed a world that's far more complex than we ever could have imagined. Antarctica is no longer just a solid sheet of ice, but a structured, varied, and deeply interconnected place that plays a much bigger role on Earth than you might expect. One of the most unforeseen discoveries beneath Antarctica is the existence of subglacial lakes. More than 400 of them are hidden under kilometers of ice, linked by networks of channels that flow like rivers. The existence of water that doesn't freeze within the ice comes down to a combination of factors. Geothermal heat from the earth below, the crushing pressure and insulation from the ice above, and frictional heat that's generated as glaciers slowly move. Satellites have revealed active lakes that fill and drain over time. Lake Vostok is a great example. It's a vast body of fresh water locked beneath East Antarctica, under Russia's Vostok station, buried below 4 kilometers of ice. The lake's surface sits around 500 meters below sea level, and it stretches about 250 kilometers long and up to 50 kilometers wide, covering roughly 12,500 square kilometers, about the size of Northern Ireland. And it's not a shallow pocket of meltwater either. The best estimates suggest that Lake Vostok reaches hundreds of meters deep, with the deepest parts approaching a kilometer down. A huge, pressurized body of water sealed in darkness. Antarctica's lakes astounded the scientific world, but what came next had them rethinking the conditions necessary for life. In 2013, researchers drilled into the subglacial lake Willens. Reaching it wasn't as simple as just drilling a hole. They had to melt a clean shaft through 800 meters of ice, treating the drilling water to avoid contaminating what lay below. And when they finally broke through, the lake pushed back, sending water surging up into the borehole in seconds. But in that freezing darkness, they discovered microbial ecosystems, surviving without sunlight and feeding on chemical energy extracted from the rocks and sediments below. Much like at deep-sea vents or in previously sealed underground caverns like the Movile Cave in Romania. These organisms were using chemosynthesis to convert the chemical energy from ammonium and minerals in the sediments into new organic matter. Life built without the sun. These discoveries prove that Antarctica is teeming with possibilities and is far more complex than we could have possibly imagined. In rare geothermal pockets, forces deep within the Earth work together to generate warmth in this otherwise frozen world. Mount Erebus, the southernmost active volcano on Earth, produces fumarolic ice caves formed by steam rising through the ice. The heat melts passages and can keep parts of the cave system warmer than the surrounding Antarctic air. These patches of warm soil are like an oasis in an otherwise uninhabitable land. DNA resembling that of mosses, algae, and small invertebrates suggests that life clings to these refuges. We're not talking about large animals or forests, but it's evidence nonetheless that even here, life can persist. Scientists believe these geothermal areas may have served as sanctuaries during past glacial ages, allowing species to survive when the surrounding continent was inhospitable. Antarctica is far from lifeless, and it goes to show that even in the last place you'd expect to find it, the flicker of life persists. In 2021, researchers drilled through 900 meters of ice on the Filchner Ronne ice shelf, 260 kilometers from the nearest open water. Under the ice, where temperatures hovered around minus 2.2 degrees Celsius, they found animals, including what appeared to be sponges clinging to boulders on the seafloor. Then, in December of the same year, a New Zealand-led team discovered a water-filled cavity beneath the Ross ice shelf. When they lowered a camera into the darkness, the lens was suddenly swarmed by dozens of tiny shrimp-like crustaceans called amphipods, bouncing off the camera. Their presence suggests a larger food web, a microbial base, crustacean scavengers, and maybe even previously unknown predators hunting under the ice. These discoveries have challenged our long-held assumptions. From the deepest, darkest parts of the ocean to caves sealed off for millions of years, to the frozen world under Antarctica, life has found a way to thrive in the most extreme environments. But as more new discoveries are made, even more questions arise. How long have these ecosystems persisted in complete darkness? Where else could there be life on Earth and beyond? And what other creatures are lurking beneath the ice? One way or another, life endures here in ways we are only beginning to understand. Year after year, snow falls on Antarctic's surface. It settles, gets buried, and slowly compresses. Over time, those layers freeze solid and turn to ice, and over tens of thousands of years, they stack up. Each layer marks a moment in time. Seasons, storms, long stretches of immense cold. Trapped inside those layers are tiny air bubbles containing carbon dioxide, methane, dust carried by distant winds, even sea salts from oceans long gone. Together, they form a direct record of Earth's past climate. Scientists extract this ice in long cylinders called ice cores, and they study them like archives. They analyze chemical signatures and isotopes to estimate past temperatures. They even match thin layers of volcanic ash across continents, locking parts of the record to known eruptions in Earth's history. As the data comes together, a striking pattern appears. Glacial cycles rise and fall, climate shifts show up again and again, and throughout it all, temperature and greenhouse gases move in close step over hundreds of thousands of years. But as remarkable as Antarctic's ice record is, it isn't perfect. Deep near the base of the ice sheet, the ice is slowly flowing and folding in on itself. And unfortunately, those movements can scramble the oldest layers, making them incredibly difficult, sometimes impossible, to interpret. It's why drilling has to be precise and clean, as any contamination risks destroying information that took thousands of years to form. Even so, scientists keep pushing deeper. They're searching for older ice and cleaner records, trying to turn Antarctica's frozen layers into a clear history of our planet. The challenges we face here aren't unique to Antarctica. Exploring subglacial lakes means solving the same problems scientists talk about when they imagine missions beyond Earth. Sterile drilling, autonomous robots, keeping human presence to a minimum, and working in total darkness, extreme cold, and isolation. In that sense, Antarctica could be a kind of practice run. A rehearsal space for exploring sealed oceans on worlds like Europa or Enceladus. And the life we've found Like microbes surviving without sunlight, ecosystems running on chemistry instead of photosynthesis, organisms enduring pressure, cold, and scarcity, has forced scientists to rethink where else life could exist. Learning how to explore and protect these hidden worlds here on Earth, we're slowly preparing ourselves for the moment we start looking for life far beyond it. In many ways, Antarctica is one of Earth's regulators. Its vast ice sheets reflect huge amounts of sunlight back into space, like a mirror that helps keep the planet cool. At the same time, the cold, dense waters that form around the continent sink and drive major ocean circulation patterns, connecting the Southern Ocean to climate systems across the entire globe. Locked inside all that ice is enough water to reshape coastlines worldwide. Ice cores show that for at least 800,000 years, CO2 cycled with ice ages, but it never climbed above roughly 300 parts per million, until the industrial era broke that limit. Today, measured CO2 is well over 420 parts per million, and that extra heat is being absorbed and moved around by the oceans, including into the Southern Ocean, where warmer water is increasingly able to reach and eat away at Antarctic ice shelves from below. In total, Antarctica's ice contains enough water to raise global mean sea level by around 58 meters, if it all melted. Even a small fraction of that would redraw coastlines. Many of the world's great coastal cities, places like Miami, Jakarta, Shanghai, and Sydney, could be swallowed outright in their lowest areas or forced into endless retreat behind walls and pumps. Some of this is already measurable. Satellites show ice thinning in specific regions, glaciers speeding up, and warmer ocean water reaching ice shelves that were once thought to be protected. From Miami to Bangladesh, seawater is already pushing into streets, homes, and drinking supplies. Antarctica may appear to be nothing more than a vast frozen expanse. But beneath the ice, things are far more complex. Buried landscapes, hidden lakes and rivers, geothermal pockets, and traces of life all reveal a continent that's far stranger and more dynamic than we ever could have imagined. With every radar survey and every satellite measurement, more of its secrets come into focus. How much of Antarctica's buried world remains unmapped? How many under-ice ecosystems exist that we haven't observed directly? And what will the future of Antarctica mean for the rest of the world?